Hello friends, today we will see about the Norton's theorem. Norton's theorem states that with respect to any pair of terminal of an active network, the active network may be replaced by an equivalent network containing an independent current source in parallel with impedance Zn. Now, the equivalent network called Norton equivalent network is the dual of Thevenin equivalent network. We have already give an introduction to the Thevenin equivalent network. You can see it on our channel. Now let us understand the Norton's theorem with an example for better consideration. Determine the current in R is equal to 1 ohm resistor of the network shown in figure using Norton's theorem. The network is given as like here. But just for simplicity, I have taken that the network in such a way that it can studied easily. For that, I have just replaced this and this in parallel as shown in here. Voltage is here, and these two resistors are here. That is just simple things. Now to obtain Norton's equivalent, we will short circuit terminal A and B, and the current through the short circuit will be ISC. Now the current source is converted into voltage source. That will be done using 1 ampere and 3 ohm. The multiplication will be 3, and this 3 ohm resistance will be connected in series while we consider a voltage source that is shown in figure. Here as shown in figure, 3 volt is here and 3 ohm resistance is here. That is made up from an 1 ohm 1 ampere current source and 3 ohm resistor. That is just simply shows all other remaining same except this resistance 1 ohm is short circuited. Now by applying KVL, Kirchhoff voltage law. According to Kirchhoff voltage law, the sum of all voltage rise is equal to sum of all voltage drop. Here we have taken for loop 1. It is for loop 1. For loop 1, 2 ohm and 3 ohm resistance are connected. Current flowing will be I1. Then minus 2 I3. This I3 current will flow from here, and which is equal to voltage rise, that is 3 volt and 1 volt. But here 1 volt is negative, by as we have considered this path flow of current I1, this plus and minus, so this voltage source will be minus, hence 3 minus 1. Same as for loop 2, 2 plus 2 resistance current I2 and 2 with I3 also consult, and voltage source by this path minus to plus, that is plus. Same way for loop 3, minus 2I1 minus 2I3, 2 plus 2I3, which is equal to 0. Now let I1, I2, I3 be the mesh current. From figure, mesh equation in matrix form will be equal to 5, 0, minus 2, 0, 4, minus 2, minus 2, minus 2, 4. The current is I1, I2, I3, and equivalent potential will be 2, 1 and 0. We have just done this matrix from these three equations. Now determinants of this matrix will be equal to 5 multiplied by 4, 4, 16, and minus 2 plus 4, that is minus 4, minus this 2 multiplied by 0 and 8, that is minus minus plus 8, will be equal to 44. That is the value of delta. Now using Cramer's rule, the Norton's current will be equal to I3. Now how we will take I3? I3 will be matrix 0, 5, 0, minus 2, 0, 4, minus 2, and this I3 line will be replaced by this voltage line, that is 2, 1 and 0, divided by determinants. Now determinants of above will be 5 multiplied by 4, 0, and this is minus minus plus 2, plus 2 multiplied by 0, and this is 4 to the 8, divided by delta. 5 multiplied by 2, 10, 8 to the 16, that will be 26, divided by 44, this will be ampere. This will be the Norton's equivalent current. Now to find an equivalent Norton's resistance, we will just simply take this circuit. In that we have to find the resistance across this. For that we will open circuit this current source and short circuit this voltage source. This will be happen through this. Here current source was open circuited and voltage source was here, which has been short circuited. Now the equivalent resistance Rn will be equal to 3 parallel with 2 plus, because it is in series, with 2 parallel with 2, as the equivalent will be 3 into 2 divided by 3 plus 2, plus 2 into 2 divided by 2 plus 2, that is 1.2 plus 1, that is equal to 2.2 ohm. Now as we have find an Rn, that is 2.2 ohm, and In, that is 26 divided by 44 ampere. This is a Norton's equivalent circuit. Now here we have already derived an In, Rn, RL is given, hence the current path flowing through this resistance will be equal to In multiplied by Rn divided by Rn plus R, that is this resistance. What is In? That we have derived is 26 divided by 44, and what is Rn? Rn is 2.2 divided by 2.2 plus 1, that will be nearly equal to 0.406 ampere. Hence the current flowing through particular resistance using Norton's theorem can be derived. If you like this video, then please share it and subscribe to our channel to get more videos. Thank you.